What's up, Fetchers of America? Today behind the camera we have the lovely Ashley. She is my daughter who goes to school at BYU Provo. Say hi, Ashley.
Hi, guys.
Oh, yep, see, she's got that sexy voice, okay? So, any of you boys out there, yeah, don't even ask. I'll kill you all. Okay, so listen, it's time for our final lecture of the semester. It's our review for the Chapter 5 test. You know that this is going to be your last test, and you can use some notes as we designated in your announcements. I'll let you look all that up to get all the details on that. I want to quickly give you an overview of what is on this Chapter 5 test. Okay, there are 25 multiple choice problems. You have access to it, honesty and integrity again. You got to follow all the rules, okay, but you do get to use some notes on this. That's cool, that's awesome. You got as much time as you want to take it, and then you can retake it, okay? And you just, again, look up the announcements to see the deadlines. I want to give you a quick overview structure of what's on the test. Numbers 1 through 11, okay? Numbers 1 through 11, almost half of the test is set from sections 5.1 to 5.6. And you got the 5 methods of factoring in there, okay? They're going to warm you up, okay? And in fact, I have a copy of the test here, and I'll just tell you right now, they're going to warm you up. And like on number 1, the direction is going to say factor out the greatest common factor. So how easy is that? They're going to tell you the method. You're just going to use method 1, pulling out the common factor. And then number 2 says factor by grouping. So you're going to know you're going to use method 2. So the first 2 problems of the test, they're going to tell you what method of factoring. But then from 3, 4, 5 on, it just says factor completely, factor completely, factor completely. Which means, like we talked about, you got to be a cancer doctor, get all that factoring done, check all 5 methods, pull out all the cancer out of these polynomials, and get her done. And then there is a problem or 2, okay, right here. So we go through all of that, and then we go right to section 5.7. And this was your last lecture that we just covered in class. Okay, Ashley, camera girl, can we see everything on the board? We got full coverage here from the camera angle?
Yeah.
Okay, cool. So in section 5.7, if you remember, we had some problems where we solved using the principle of zero products. If you go back to your lecture, everything here, 12, 13, 14, 15, 16, 17, is organized just the way we taught it to you in the lecture. I showed you problems where they had stuff like, x plus 2, times x plus 3 equals 0. And they've already taken the quadratic equation, put it in standard form, factored it, and then they came up with this. And so in those 4 steps, they took the 2 steps and did it for you, and you just take this and say, well, yeah, x plus 2 equals 0, or x plus 3 equals 0, and then solve each equation, subtract 2, x equals negative 2, here we subtract 3, and we get x equals negative 3, and we're done. And so you have 2 problems where all you do is solve using the principle of zero products. And then 14, 15, and 16 from section 5.7, solve using the principle of zero products and factoring. This requires you to use all 4 steps of your solving quadratics that you learned. And then we had this one problem here where you found the x-intercepts of the graph of the equation, okay? And that would be, if I had x squared minus 5x plus 6 equals 0, and I said, find the x-intercepts, okay? There's nothing different from saying find the x-intercepts of that equation and solve that equation, okay? Because we learned that x-intercepts are indeed solutions. They are solutions to this quadratic equation. And so we would solve this equation, and then when we got an answer, so we'd say, okay, let's factor this. And again, we're gonna go through this in a review in a moment here, so I'm gonna hold off on that. 18, 19, and 20 are word problems. You have 3 word problems. We gave you practice in each of these. Your lecture at 5.8. There's going to be 1 consecutive integer problem, 1 geometry problem, 1 Pythagorean theorem problem. And then your last 5 problems on the test, 21, 22, 23, 24, 25, those are going to be retro problems from previous tests, okay? So that's a quick overview. We're going to break this down into components and review it. So I got to tell you guys that we're going to do this review a little bit backwards, okay? So you'd probably be happy if I went through these and then went through this and went through all this. But I'm going to put the emphasis on the things you need the most help with. So we're going to start off by actually talking about your word problems and doing those together. And we'll kind of go from there and return back to some of this. Again, though, this is really covered in your last lecture. So I mentioned to you before, we're not going to review this extensively. But we're going to pause for just a second, and we'll be right back. Okay, my fetchers. So the thing we struggle with most and always have is word problems. You have 3 of them on this test. You actually have 4. I hate to break the news to you. One of them is in the retro section. You're going to be like, Brother Rich, don't do this to me. Okay? Yeah. I was thinking, anyway, sorry. I'm going on rando thoughts here. So, one of the word problems is an integer, a consecutive integer problem. So I told you number 18, 19, and 20, quadratic equation word problems. There is a consecutive integer problem. There is a geometry problem, and there is a Pythagorean theorem problem that we discussed. Ashley, can you see all that in the camera? We good?
Yes.
Okay, cool. All right, so let's do this problem, folks. Let's do this one together. The product of 2 consecutive integers is 19 more than their sum. Find the integers, okay? So let's think about this for a second, okay? We have 2 consecutive integers, all right? So we have integer number 1 and integer number 2, all right? Now remember, when we have consecutive integers, okay, the first one is always x. That's right, because we always start with x, okay? You can chant that, and you can, count. If you want to go to sleep at night, some people count sheep. I just, we always start with x. We always start with x, okay? Until I go to sleep, all right? Check it out, okay? So our first is x, because we always start with x. Now, notice that we always have to ask ourselves, are we dealing with the product of 2 consecutive integers or 2 consecutive even or odd integers? This one just says consecutive integers, so the next one is, that's right, x plus 1. Okay, so if I had 2 plus 1 would be 3, those are consecutive integers, and we're good to go. Okay, so we like that, we're saying, yep, that's cool, man. Okay, now think about this, okay? If you think about this, you have the product of 2 consecutive integers is 19 more than their sum, and so find the integers. Product means what? It's the answer to a multiplication problem. Sum is what? It's the answer to an addition. So this is addition, this is multiplication, and so if you think about it, we're going to take the first and multiply it times the second, or here we're going to take the first and add it to the second, okay? But it's saying the product is 19 more than their sum, okay? Now I need you to totally follow suit with me here. The product of 2 consecutive integers, product is, means equals, 19 more than their sum, 19 plus the sum. Okay, I want you to look at this again. It says the product, so there's the product, is means equals, 19 more than, 19 plus, right there, their sum. There's the sum, okay? So what is the first? The first is x. What is the second? It's x plus 1. And because it's the product, we're multiplying them. 19 plus, okay? The sum, okay, is going to be the first plus the second, which would be x plus 1. And you can put a parentheses here if you wanted to. Okay, do you need the parentheses? What's the distributor? It's just 1, so 1 times anything remains the same. And so we could get rid of this parentheses right here, because we really don't need it any longer, okay? All right, cool. And so in essence, I want you to see this one more time, because sometimes I tell people, hey, the product is 19 more than the sum, and they put the 19 with the product. Think about it. The product is already worth more than the sum. To make them equal to each other, we got to put 19 on the side of the sum so that this is balanced out. The sum is going to be less than the product, so if we add 19 to it, they'll be balanced. They'll be equal with each other. X times x is x squared. X times 1 is plus x. We have like terms over here. I mean, we got to simplify this equation, all right? We distribute parentheses, we combine like terms. And what have we talked about when it comes to solving a quadratic equation? Ashley, can you see everything over here? We're all good?
Yeah.
Okay, so if we're solving a quadratic equation, and we remember there's 4 steps, okay, to doing this, And step number 1 is to put it in standard form. But we talked about this. Sometimes we have to simplify the equation before we can get it in standard form, which we talked about deals with, same thing as always, getting rid of fractions, distributing parentheses, combining like terms, all that kind of stuff, okay? The second step is to drop the F-bomb, factor everything. Third step is to apply the principle of zero products. And the fourth step then is to solve each equation. And that's going back to the good old-fashioned 3-step process to solving. Because we talked about we only know how to solve linear equations, so we're using factoring and the principle of zero products to get this quadratic equation right. And so we can solve it. Look at this. X times x is x squared. This makes a quadratic equation. Now we got to combine things. 19 and 1 make 20. X and x, that makes plus 2x. And then we got to get everything on one side in descending order, all set equal to 0. So we're going to subtract 2x, and we're going to subtract 2x. And that's going to give us x squared minus x equals 20. Well, these cancel. We still don't have everything all on one side in descending order. We got to subtract 20 and subtract 20. And then I'm going to bring this on up here so we can see it. X squared minus x minus 20 will equal 0. Okay, because these will cancel, make it 0. And this will be x squared minus x minus 20 equals that. We bring it up here. Now we got to factor. All we've done right here is step 1. Okay. So step number 2, we got to factor. So we know that c equals negative 20 and b equals negative 1. And we say, yeah, 5 times 4 makes 20. If I have negative 5 and positive 4, that makes negative 20. Add together makes negative 1. And so I can say, yeehaw. Okay, x squared is x and x. These drop down, negative 5, positive 4, set it equal to 0. And now I can apply the principle of zero products, which says that x minus 5 equals 0, or x plus 4 would equal 0. Now if I add 5 to here and add 5 to here, I get x equals 5. And if I subtract 4 here and subtract 4 here, I get x equals negative 4. Now it's time to do some thinking. We've come up with some solutions to this word problem. You have a word problem like this on the test. Okay? And so I don't want you cheating or anything. I just want you understanding this concept, and then you can get into that test and go crazy. Okay? Check it out. In some word problems, we eliminated the negative answer. I'm going to ask you this question. I asked it to you in the last lecture on section 5.7 and 5.8 word problems. Can an integer be a negative number? If you said no, I'm going to reach through the camera and squeeze your neck, okay, until your brain pops, okay? Yes, integers by definition are both positive and negative. So both these answers can be true. Now I said find the integers. Now let's think about this. If integer 1 is 5, then integer 1 is 5 plus 1 is 6. So our first set of solutions is 5 and 6. Okay? But our next set of solutions are negative 4. Okay, so we put negative 4 in here. Negative 4, so we have negative 4. And negative 4 plus 1 makes negative 3. Those are consecutive integers as well. Now just for kicks and giggles, let's try this out. Okay? The product of 5 and 6 is 30. The sum of 5 and 6 is 11. 30 minus 11 is 19. Look at that. So the product is 19 more than the sum. The product of negative 4 times negative 3 is positive 12. The sum is negative 7. Okay, notice how we subtracted these. We would subtract these. 12 minus negative 7 makes 12 plus 7. Ding, ding, ding. Makes 19. Okay, so both sets of solutions are true. Okay, true. All right, Ventures of America. That's one of our 3 word problems. Okay, take some notes. Think about this for a little bit. Okay, we're going to pause. Okay, guys, one of the things I'm going to do for these problems here is, on most of them, I'm going to try to give you one that you can work on yourselves. We do not have enough time. I mean, it would take like 2+ hours of videography, and you don't want to watch that much. But here's another one similar to this that you can practice, see if you can do it right. The product of 2 consecutive integers is 41 more than their sum. Same exact problem, but now this number has changed. Here's your answers. Why don't you see if you can come up with this set of answers on your own? If you can't, this is something that you'll want to reach out to the tutors or chat and see what you can come up with. We're going to hit pause again and do your next word problem. So, okay, so we have covered the consecutive integer problem. Okay, there's a geometry problem, and it's similar to the one on the board here. The length of a rectangular picture is 8 inches more than the width. The area is 128 inches squared. Find the width of the picture. Okay, so people, this is one just like the ones you did in your homework. There's a comparison statement. We've talked about this a million times. The length of a rectangular picture is, so length is means equals 8 inches more, 8 plus the width, W. So L equals 8 plus W. They're talking about area. They're talking about a rectangle. The area of a rectangle, area equals length times width. And we talked about this. That, you know, I mean, if you go back to the consecutive integer one, we were never able to do sum or product of consecutive integers because it would make an x squared. And we only did perimeter in the past. We can finally do area because we could be multiplying the variables and come up with a squared variable, because now we can solve quadratics because we know how to factor. Well, it says the area is 128. It says the length is 8 plus W. 8 plus W, and width is W. And we talked about how this distributor, doesn't matter that it's on the tail end, it will still work here, okay? 128 equals W times 8 is 8W. W times W is W squared, all right? So we come up here and we say, we've got W squared plus 8W on one side of the equal sign. Notice how I rearranged them, okay? So if I subtract 128 and I subtract 128 from each side, this will cancel and I get 0 equals, but I got to put that in descending order. So the W squared goes first, then 8W goes next, and then minus 128, and this was all, you know, equal to 0, because it doesn't matter what side it's on. And then what we've done is we put this in standard form. We now need to factor it. So we say C equals negative 128 and B equals positive 8. And this becomes kind of challenging. I mean, you're going to have to get your calculators out and fetch around here with things that when multiplied together make 128, when added together make 8. I would recommend that you experiment with numbers that make sense. This is 128. So I would experiment on your calculator. Ashley, help us out here. You can go on calculator mode. We know it's an even number. If we do 2, 2 goes into 128 like what?
128 divided by 2, 64.
Yeah, 64 times. And so, you know, we get this up here, 2 and 64. If this is negative, to make this negative, I mean, this is going to give you 62, which is a far cry from 8. So we definitely need to bring it in tighter. Can I show you something interesting, though? If you're struggling when you do this, the reason I went to this extent here is if you're struggling with this, you can factor things that go into 64. They also will go into 128. What's a number that goes into 64? Can you think of one, Ashley? It's okay if you can't. I mean,
8.
8. Very good. 8 times 8 is 64. Okay, and so that's really apparent. So then try 8. So put 8 in and do 128 divided by 8. What do you get?
16.
There you go. So we have 8 and 16. Well, check this out. You found your magic pair, because negative 8 times positive 16 will make negative 128, but when added together makes positive 8. And you were able to determine that by just picking a simple number that you know could go in here, but it really didn't work out. But it lessened this number so you could break it down into other factors, because the factors that go into 64 also have to go into 128. They have to, because 64 is a factor of 128. And so now we have, in essence, 0 equals W and W, because W and W make W squared, minus 8 and plus 16. Okay, we can apply the principle of zero products now. W minus 8 will equal 0, or W plus 16 would equal 0. If we add 8 and add 8, we get W equals 8. If we subtract 16 and subtract 16, we get W equals negative 16. Now, in our consecutive integer problem, I asked you the question, can we have negative numbers in a consecutive integer problem? And the answer was a resounding yes, because integers can be negative. But I'm going to ask you, Ashley, too, join in with us here, okay? If I have a rectangle, people, okay, and if I have this is a picture, and it says, you know, this is the length, this is the width, you know, and we're saying, hey, you know, this is 8. Okay, well, I'm asking you, could the width be negative 16? Could the width of a picture be a negative number? Yes or no?
No.
No, I mean, it's just, this is the real world we're dealing with here, okay? And so this answer, okay, it cancels itself out. Gone, okay? And so the only viable solution is W equals 8. They ask you to find the width of the picture, you're done. It's 8 inches, and that's it. You don't need to find the length. Okay, the length does happen to be 16, but they're not asking because 8 plus 8 makes 16, but they were just asking for the width. Okay, we're going to pause for a second, and when we come back, we're going to give you a practice one. Go for it. Okay, so here is a practice one. Same type of problem, different numbers. The length of a rectangular picture is 6 inches more than the width. The area is now 216 inches squared. Find the width of this rectangular picture, okay? The answer to this is 12. It's 12 inches. Do this one on your own. Again, if you can't figure it out, get some help with tutors, and we'll go from there. We're going to hit pause, let you mess with that. We'll come right back. We're back again, Ch.5. Okay? All right, so we have done the consecutive integer. We have done the geometry, and now we're going to do the Pythagorean theorem. So, putting a lot of time into your review into these 3 word problems, and it's because word problems are the ones you struggle with the most, okay? Trying to help you out here. This problem, okay, well, it sucks with a capital S. Capital U, capital C, capital K, capital S, okay? But the bottom line is I'm going to help you with it, okay? And so here we go. 2 cars leave an intersection. One car travels north, the other east. You have to understand they're trying to create a Pythagorean theorem problem, okay? So you know this car traveling problem is all about creating a right triangle. So think about this. If you have a road that's going north and a road that's going east and west like this, okay, and you have a car right here and it starts at this intersection and goes whoop, and it travels north to this point right here, and you have a car right here, okay, and it says boop, and it's traveling this way east, okay? You think about this, this right here makes a right angle. Now the distance between the cars is the hypotenuse, okay? So this is the distance between the cars, okay? And then this statement right here from here to here, okay? This is the east, you know, distance, okay? And then this distance from here to here, this is the north distance, okay? Because on a map here, you know, in 2 dimensions, north means to go up, okay, east means to go right, or west means to go left. I mean, look at a map of the United States, California, west, left, okay, all right, Washington, D.C., right, you know, east, all that kind of stuff, okay, we're cool? But this makes a right triangle, and that's the whole thing, this is what the Pythagorean theorem says. And if you think about it, we know that, okay, the legs of a Pythagorean theorem, so basically the north squared plus the east squared will equal the distance between the cars squared, okay? The distance between the cars squared, okay? A squared plus B squared equals C squared, leg squared plus leg squared equals hypotenuse squared, okay? And so we come back to this, and I just tell you this, that this was the car traveling north, and the other went east. We took care of that. It says when the car traveling north had gone 20 miles. So here's the nice thing. They're telling you that this right here is 20. The north distance is 20. So we got 20 squared. That's nice. We don't have to do any real deep thinking on that. They gave us the goods. It says the distance between the cars is 10 miles more than the distance traveled by the car heading east. How far had the eastbound car traveled? Well, the one thing we always know is that the unknown, the last sentence, is going to be our variable x. And so eastbound traveling car is going to be x, okay? So north is 20, but east is x, okay? So we're going to have plus x squared. But they tell you something interesting here. They tell you that the distance between the cars is 10 miles more than the distance traveled by the car heading east, okay? Or than the car heading east, or something like that, however it's worded in your text. Well, here's the deal. They're basically telling you this distance from here to here is 10 more than this. Well, that's 10 more than x. It's x plus 10, or 10 plus x. Okay? And so then this becomes x plus 10 quantity squared. Not x squared plus 10 squared, x plus 10 quantity squared. Okay? Because this is the hypotenuse. This entire value has to be squared. And then we gotta do our math here, okay? We gotta simplify this equation. 20 squared, put it in a calculator, you get 400. X squared is x squared, and x plus 10 squared, okay, fetchers of America, we know how to multiply this. We've been through this a whole bunch of times. I'm gonna ask you this, okay? I'm gonna ask you to be gnarly here with me, okay? But listen, x plus 10 squared. Can we just say x plus 10 squared equals x squared plus 100? Can we just bring the square to each thing? Fetch no. We've talked about this. Wrong answer. We cannot take a shortcut and just bring the square to everything. We have to take x plus 10 times x plus 10, and we're going to get x times x plus, x times 10 plus 10 times x plus 10 times 10. And this gives us x squared plus 10x plus 10x plus 100, which in the end gives us x squared plus 20x, because these two combine, plus 100, okay? Now that we figured this out, okay, we have a quadratic equation because we have x squareds. We got to get all this crap over here. So the first thing we got to do, let's subtract x squared. What we do to one side, we got to do the other. Let's subtract x squared. Now something fascinating happens here. I want you to really watch this. These bad boys cancel out, okay? I guess if that's sexist, we'd call it bad girls too. Whatever makes you happy, okay? Bad boys, bad girls, just keep it equal here, okay? Next problem, we'll call it bad girls, okay? But I don't know. Ashley's, she's feeling good about this. Okay, so check it out, okay? These cancel out right here, and we get 400 equals 20x plus 100. People, do we have a quadratic equation anymore? No! Remember, we can't solve quadratic equations. We have to factor them to turn them into linear equations. Well, people, when we subtracted x squared from each side here, they canceled each other out. We have a linear equation. We don't need to factor this, okay? We can just simply solve for x minus 100, minus 100, and we get, 300 equals 20x. We're going to divide by 20 and divide by 20. Ashley's got the skills to pay these bills. I think I have the answer. I bet I can do this. 300 divided by 20 in my head, x equals 15.
That's why he's the professor.
Hey, professore! That's right, man. So, there you go. 15. 15. So the distance of the eastbound travel car is 15 miles. This is a challenging problem. Okay, this kind of kicks people's butts sometimes. Okay? Not just sometimes, a lot of times. So we're cool. One other thing I want to show you here, when we got to 400 equals 20x plus 100, at this point here where the x squared's canceled out, let's say that you decided, hey, I do want to factor this. I'm going to treat it like a quadratic, where you got everything on one side in descending order set equal to 0. Let's say that you kind of jack that up. It would really be kind of crazy, but let's say minus 400 and minus 400. And this cancels, and you get 0 equals 20x minus 300, okay? Your common factor here ends up being 20. Really interesting. If you were to just factor this, even though it's not a quadratic, let's say we factored it. 0 equals, we'd have 20, because we factor out a 20 here. We'll divide this by 20, we divide this by 20, and we get x minus 15. What's so interesting here is the principle of zero products would work here if you did end up going this route, because you would either say, hey, 20 equals 0, which we talked about. And obviously 20 does not equal 0, but then you would have x minus 15 equals 0. When you add 15 to each side, you will get x equals 15. So if you didn't go straight to the linear equation option here and you tried to factor this out this way, it would still work. Just wanted to show you that. Okay, we're going to hit pause in a second, okay, and we're going to give you another one of these to work on your own and see if you can do it. Again, if you can't, you're going to need to get some help. But take a little moment, study this, really understand it. We'll be right back. Hey fetchers, we're back. So a practice problem for you. The numbers are going to be pretty robust here. Okay, so you're going to need some calculator help. But two cars leave an intersection. One car travels north, the other east. Same exact setup as the last problem. when the car traveling north has gone 400 miles, and I've left the diagram up here, okay, so when this car has gone 400 miles, always good for you to label your diagrams, okay? The distance between the cars is 200 miles more than the distance traveled by the car heading east. Again, the eastbound car is what we don't know, so you should label that X, and that over there should be X plus 200. But I want you to mess with this, okay? So let's just do this. This will be X, and this would then be X plus 200 because it's gone 200 miles more. The distance between the cars is 200 miles more than the distance of the eastbound car. This ends up being 300 miles. Go ahead and you do this one on your own. Again, if you need help, reach out to the tutors. Okay, we're going to pause. Okay, fetchers. So I told you we're going to kind of jump around this review. We're starting kind of towards the end of the test. We've gone over the 3 word problems. I actually want to go over the retro problems with you briefly. There are 5 retro problems. If you look here, Ashley, can you see all this in the camera? Have we lost any angle here?
No, it looks good.
Okay, cool. So number 21 through 25, there are 2 problems from chapter 4, laws of exponents. Okay, we're going to go over those first. Okay, there's 1 problem from chapter 4, evaluate the polynomial. There's 1 problem from chapter 3, graphing an equation, and there's 1 problem from chapter 2. It's a word problem and it's an average word problem. We're going to go through all of these. So let's first talk about the laws of exponents. All right. So you're going to see a problem like this. Definitely going to be utilizing the power rule here. Okay, the power rule says that everything in the parentheses receives the power. Everything in the parentheses receives the power. So if you look at this, we have right now, we actually have negative 2 to the first and a to the fourth when you really, really think about it. Now, do we have a problem with negative big numbers? No. We have a problem with negative little numbers, but not negative big numbers, okay? This is all being raised to the second power. So this has to go to here and to here. This is going to be negative 2, which is going to now be squared, a to the 4 times 2, which would be a to the 8th. Now, I want you to think about this negative 2 squared thing, all right? If we square that negative 2, it becomes a positive 2, right? And so we would have negative 2 times negative 2 makes positive 4a to the 8th. I think this thing's really, really important because we've talked about the concept of negative 2 squared versus negative 2 squared. We talked about how this ends up being negative coming along for the ride, but 2 times 2, which would be negative 4 in the end, where this is negative 2 times negative 2, which is positive 4 in the end. Remember, what's being squared here is this whole negative 2 thing, okay? So that becomes a positive, all right? We cool with that? Okay, the next thing. This one here is going to be the negative exponent rule, okay? So you got to review the power rule and the negative exponent rule. The negative exponent rule says you can't have them, right? And we're going to take that and put it in its opposite place in the fraction and call that 1 over 5 to the 4th, okay? 1 over 5 to the 4th. Now, one of the things that I want you guys to remember about this is that in your testing situation here, is there a chance that they could multiply this 5 to the 4th out? For sure. For sure. Another answer for this, would it be 1 over 20? No, absolutely not. 5 times 4 doesn't make 20. This would be 1 over, 5 times 5 times 5 times 5. Actually, I believe this is 1 over 625, but will you check it for me? 5 times 5 is 25. 25 times 5 is 125, and 125 times 5 is 625, I believe.
Yes.
Yep, so this is 1 over 625. If they left it in exponential form, this would be the answer. If they multiplied it out, this would be the answer. You have a calculator. You can do this. If you say, well, which one are they going to want? We've talked about this before. They're only going to give you one correct answer, okay? It's either going to be this or this, and you'll know. You'll look at it, and they'll either have it left in exponent form, or they'll have it all multiplied out for all your options, okay? Let's go ahead and pause for just a second, Ashley. We're going to go over these other problems. What up, what up? Okay, so this problem looks way bigger than it is, okay? On the test, the print of it will not take up so much space, but I wanted to break this down for you. Definitely you're looking at this going, holy fetch, this looks like a word problem. We've talked about this before. This is a little sheep, okay, in wolf's clothing, right? So this looks like a ravenous wolf, but it's really just a little baby. I just can't stop. Okay? All right, so Do we want to make any other barnyard noises today, Ashley? You got one you want to do?
That's okay, I'm good.
What? Come on, man! Okay.
Dad can do a pretty good chicken though.
I can do a chicken. You guys ready? You want the chicken? You want the chicken? I can't even do it all out. Okay, check it out. A realtor can use a linear model to predict the price of a house, P. So I want you to understand this. The price of a house is P. Based on the size of the house, S. So price P, size S, in square footage. The size is in square footage. Assume that for a local real estate market, the equation is P, right? Price of the house equals 102 times the square footage plus an additional $22,500, okay? This is a little equation. I want you to think back. We have done a bunch of these problems in the past. These are simple substitution problems, substitute, where they're going to give you one of these values, P or S, and typically they give you S, and then you figure out P. And so we come over here, and the second part of the problem says, using this model, basically the polynomial equation, which of the following home prices would be reasonable for a realtor who is selling a 2,200 square foot house? So, and then they'll give you a bunch of different, options, A, B, C, and D. And I'm not going to give you all those. But basically what we do here is, this is a 2,200 square foot house. So that number 2,200 either has to go in for P or it has to go in for S. You only have two options here. Okay? And when we think about it, size of the house in square footage is S. This is square footage, so S is 2,200. So we have P equals 102 times 2,200 plus 22,500. Okay, my barnyard friend Ashley, okay?
Yeah.
Will you pull out your calculator here?
Sure.
So P then would equal 102 times 2,200, okay? So that's going to give us, what?
224,400.
224,400 plus an additional 22,500, and then we add all that together, and the price of this home, a reasonable price for the realtor to ask for this home, would be $246,900. Is that right?
Yes.
Okay. Hard or easy, people? Well, this is an easy problem, but if you look at it on the test and you've never reviewed, this could overwhelm you, okay? A lot of verbiage here. Looks like a big old beastie word problem. Remember, it's just a little baby sheepy, okay? We're going to pause. Okay, so we've spent a lot of time on this one single problem, and we said, hey, this is an easier problem, but, sometimes problems like this can be challenging because they're really real-world problems. It's not a word problem in the sense that you have to do all this figuring, but at the end, you got to think about the answer. I want you to look back at the question here, and Ashley, maybe you can help us out here. It says, using this model, which of the following home prices would be reasonable? I think this word right here, reasonable, should kind of arouse your danger, kind of senses, because math isn't about reasonable. Right? It's either right or it's wrong. But in the real world, we deal with math all the time where we have to kind of reason through stuff. Selling a home is not always a precise equation. And so we come up with this price right here of $246,900 when we did the math. And then we have these four options here. 220,000, 180,000, 280,000, 250,000. I think the thing that you would ultimately come with, Ashley, what would you pick?
I would choose D because it's only 4,000. It's less than 4,000 away from our answer.
I love Ashley's reasoning there. Ashley's a college student like you guys, and she's using her powers of deductive reasoning, and she's saying, hey, this is the closest answer to this, and she's right. That is the correct answer. That's a reasonable price to ask. Some people could say, well, wouldn't 220,000 be reasonable? It would be a low ball answer. $30,000 is a lot of money to lose in a market where you're trying to get the most for your, value for your property. So you would want to be closest to what the equation takes you to. And so you are going to have to round in this answer And that is one aspect of this problem that you want to be aware of, okay? So Ashley was absolutely right. You want to pick the answer that's going to be the closest to where this equation gets you. Let's pause. Okay, so we have covered on our review the laws of exponent problems. We just did the evaluate polynomial problem, which was kind of a little bit more complicated than we wanted it to be, but it is what it is. Now you know how to do it, so you better get it fetching right, okay? I don't want anybody jacking that one up. And then we have a graphing problem from chapter 3. We want to graph an equation. Can I just tell you folks, check this out. There are 3 methods of graphing an equation. Plug and chug, intercept method, y equals mx plus b. This bad girl, we said we would do that actually, this bad girl is in y equals mx plus b form for you. So really it's a good girl because this is so nice for you. Are you fetching kidding me? M equals 1/3, b equals -2. Draw your graph, you know? This is your x-axis, your y-axis. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And we have a y-intercept of -2, boop, okay? And the slope is 1/3, okay? Which means 1/3 equals rise over run. So you're gonna go up 1/3 and connect the dots, okay? I'll do one more for you. Let's say that y equal 2x minus 5, okay? Y equal 2x minus 5. Let's do this one, okay? Check it out. Again, y equals mx plus b, m equals 2, or also known as 2/1, and b equals -5. We're going to go down 1, 2, 3, 4, and 5 right there, boop, okay? And we're going to go up 2 and over 1. And there's our line, you know, going up like that. You could have done it that way, okay? You guys know how to do this. We're going to pause. All right, fetchers, the last retro problem is a word problem. And we're basically trying to see, you know, this is a good word problem, the average word problem, okay? So we have an average. And this is a great problem because we use this a lot when we're in school. We're going to use Fetch Daddy as an example because Fetch Daddy is fetching it up and he has got, you know, a C minus and a C plus, but he really wants to get a B in his class, and an 83 or greater constitutes a B. Okay, so you know this is an inequality word problem because we're saying or greater. But we talked about we don't need to worry about the inequality, just treat it like an equal sign. And so remember, in an average problem, big A stands for average equals, and there are 3 tests here, test 1 plus test 2 plus test 3, okay? All divided by the number of tests, which is 3 tests, so we divide this by 3. Since the average, we want it to be 83 or greater, so we just say 83 equals, okay? Test 1, everybody, that's 70.5. Test 2 is 78.25. Test 3, well, it's the one we haven't taken yet. What score must he get on exam 3? So Fetch Daddy has received scores of 70.5 and 78.25 on his first 2 tests. What score must he get on exam 3 to keep an average of 83 or greater? Well, test 3 then is going to be X, because it's the one we don't know, all divided by 3. We've discussed this over and over again this semester, okay? Do we have fractions? Okay, 3-step process to solving? Yes, we do. We multiply this side by 3. And we multiply this side by 3. Ashley's going to get out a calculator. We're going to cancel these 3's out, okay? 3 times 83 makes 249, is that right? Okay, so we have 249 equals 70.5 plus 78.25 plus x, because these canceled each other out, the 3's did, okay? And then we can combine these like terms right here. Go ahead, Ashley, and add 70.5 plus 78.25.
Okay. 148.75.
148.75 plus x. Okay. This could be pretty gnarly. Okay. Let's go ahead and subtract 148.75 and subtract 148.75 from both sides.
Okay, 100.25.
100.25 equals x. Okay, so this is kind of interesting. Okay, Fetch Daddy is fetched because you can't get 100.25 on the test. Okay, And so that's why I called him Fetch Daddy, is he's kind of fetched things up, and it's a little too late. He should have retaken those other 2 tests and got a little higher score, because it's just going to be tough for him to average an 83. So let's do this. Let's change this number. What if this was, check this out, what if Fetch Daddy got an 88.25? Okay, and then this becomes an 88.25, and this becomes an 88.25. So now, actually, would you add those 2 numbers together? 70.5 plus 88.25.
Okay, that's 158.75.
Okay, 158?
Uh-huh.
Okay, so it's just going to change this digit right here, which makes sense because we just changed the digit. And then if we subtract 158 from each side, now this becomes 90.25, is that right?
Yes.
Okay, and so now, check this out. Fetch Daddy, well, he's not so fetched up anymore, okay, because he's got a chance. You're telling me there's a chance. Not a big one, but there is a chance, right? Now, here's the deal. On the test, they're asking you, okay, if, what are the scores that, Fetch Daddy could get here? So we ultimately can say X must be at least 90.25, because, up here, we want this to be at, he can get 90.25. So we can say X is greater than or equal to 90.25. Either one of these answers, written out like this or in this inequality format, would be correct. Fetch Daddy can get a 90.25, he can get a 91, 92, 93, 94, 5, 6, 7, 8, he can get 100. But he can't get less than that, or he will not average at least an 83. This is the end of the retro question review. We're going to pause for a second, and we're going to come back and do some others. What up, Fetch guys? Ashley, how are we looking on there? Can you see everything okay?
Yes.
Yeah? All right, cool. All right, so for this portion of the review, all right, we have, like I said, we're working kind of backwards. We've gone through the word problems. We have gone through the retro problems. And now we're going to talk about the stuff that is from, can you see this, Ashley, section 5.7? Can you see that?
Yes.
This is from section 5.7. There are 6 problems from section 5.7. In section 5.7, we learned how to solve quadratics, this 4-step process. Super condensed here, put it in standard form, factor everything, apply the principle of zero products, solve the remaining equations using the 3-step process. We said this before, we don't know how to solve quadratic equations. And so the factoring and the principle of zero products breaks them down into 2 linear equations that we can then solve. Listen. This is organized just like the homework. You can review your notes. You can review the lecture, the video from section 5.7. I think this is, for many of you, kind of a section that you don't need me to review. But I'm going to quickly go through it. Okay? We take this process, and in the beginning of the chapter, we cut it in half. If we remember, this was part A of the homework, and they did the standard form and the factoring all for you in the beginning part, and you just had to apply the principle of zero products. So we look at something like this, and we say, yep, x minus 5 must equal 0, or x plus 7 must equal 0. We're going to add 5 and add 5. We're going to subtract 7, subtract 7. Here we're going to get x equals 5. Here we're going to get x equals negative 7. Super easy, super fast. That problem's done. Okay, this one right here. X times x minus 7 equals 0. Therefore, x equals 0, or x minus 7 equals 0. Of course, this answer is already done. X equals 0. Here we add 7 and add 7. We get x equals 7. So you get 2 problems like that. Those should be super duper easy for you. I'm going to quickly erase those, okay? Because if you want to take some notes on them, you can pause. But I want the extra board space to handle this next portion. So in numbers 14, 15, and 16 on the test, you're doing all 4 steps of solving quadratics, okay? And so let's do the first one, 12x squared minus 7x, 12x squared minus 7x equals 0. First thing we do is we put it in standard form, ding, ding, ding. Everything's on one side, descending order, set equal to 0. They've already done it for you. We're going to factor all. Okay, and we got to look at every factor problem. We first check for a common factor. Do we have one? Yes, we do. We pull out an x. We put this over x, we put this over x. We get 12x minus 7 equals 0. We got a binomial. We check to see if we have a special case. Hey, numerically 12, 7. Do we have a common factor? No, it was just the x. We pulled out the common factor. Then we go through all of our factoring methods. We're at binomial here. We check for a special case. Is 12 a perfect square? No, it's not. We cannot factor this anymore, so we move on. So if you come back, you dry your eyes over here. Okay, at this point in the test, you know, we're getting rid of that little divider. We're using all 4 steps. Solve by factoring and using the principal of zero products. This is part B in the homework. Again, the directions in the homework are exactly like the directions on the test. Okay, the first one was just solve using the principal of zero products. Now we're going to use factoring and the principal of zero products, which is telling you everything. Okay, and so therefore x equals 0 or 12x minus 7 equals 0. Obviously this one's done, x equals 0. Here we're going to add 7. We get 12x equals 7. We divide by 12, divide by 12, and we get x equals 7/12. So there's our 2 answers to that first problem right there. All right? So, going to erase that. Okay? And our next problem here. All right? Okay, this is a good problem because it reviews the most challenging of all the factoring methods for you when a does not equal 1 in a trinomial. Okay, solve by factoring using the principal of zero products. Got to use the whole process. We put it in standard form, which means everything on one side in descending order, set equal to 0. It's been done for us. Let's say this said 3x squared minus 7x equals 20. Okay, is that in standard form? No. So we would have to subtract 20, and then we would get this. Okay, so if that comes up on the test, you'll take care of putting it in standard form. You're going to factor everything here. Factor everything, okay? Check for a common factor. Does 3 go into 7? No, so you don't have a numerical one. X, no X. You check for a common factor. Factoring by grouping won't work because you don't have 4 terms. Method 3 won't work because a doesn't equal 1. The only method that will work right now is method 4. So we got to take a times c, which is 3 times negative 20, which makes negative 60, okay? B equals negative 7. So we got to find 2 things. Multiply together, make negative 60. When added together, make negative 7. All right? All right, folks. I'm going to take advantage of this opportunity. Ashley, camera girl, just check one more time. How's the camera looking? Everything going good?
Yep.
We've had a few technical difficulties in our videography tonight. This is only the second time that we've done this exact same lecture for you. You don't know, but we know it. So hopefully this will work out. We've done pretty good with all this, but you know, taking videos with your phone, sometimes your phone gives up the ghost, and so hopefully we'll get through this. If we don't, I don't think we're going to do it a third time. So you guys all on the other end better be praying this works out. We're about done. Okay, so here's the deal. If you know your times tables, you can immediately figure this answer out. But I want to show you something interesting. We once told you that in this method, you could take these 2 numbers, 3 and negative 20, work with them immediately. Yep, that's going to be negative 17. Does that number need to be bigger or smaller, right? And we don't think about the negative, so we're still getting 7 and 17. And so the number needs to be smaller to be 7, which means that, you know, on a scale of 1 all the way to 60, that between 3 and 20, if this number needs to be smaller, the magic pair lies in between 3 and 20. So you don't need to worry about any of this. It's somewhere between, you know, 4 to 19, okay? And so you can start messing around with things. Sometimes people say, well, I recognize 6 and 10 lie in between those. Yeah, they do. So 6 and negative 10, that would make negative 60. When added together, make negative 4. Now you need your number to be bigger or smaller. You need it to be bigger. So you think about this. If you take 6 and 10, those lie in between these, okay? But you need your number to now be bigger, which means it would lie outside of 6 and 10, but still in between 3 and 20. So that only leaves 4 and 5, okay, and 11 through 19. And one of them has to be one of these numbers, and one of them has to be one of these numbers. This is something we talked about a while ago. Okay, now if you remembered your times tables, you knew that 5 times 12 made 60. 5 times negative 12 make negative 60, but when added together it makes negative 7, and that gives you your magic pair. But I want you to see that 5 and 12 lay in between 3 and 20, but outside of 6 and 10. because of all the stuff we went through there. All right? So now we have to take this, and we're going to take this and just write it here. 3x squared minus 7x minus 20 equals 0. We got to break bx up into two terms based on the magic pair we just found. So this is going to be 5x minus 12x. The minus 20 comes down, the 3x squared and the plus come down. Okay, because that's a positive 5x. This equals 0. We have four terms. We can now factor by grouping. We're going to take 3x squared and 5x, negative 12x, and 20. Put a plus in between them. Common factor here is x. Put that over x, put that over x. We get 3x plus 5. Okay, my common factor over here, okay, folks, we have to factor out a negative to make these positive to match this here. But if you wanted to, you could say, okay, 4 is my common factor. Let's say positive 4, put this over 4, put this over 4. You would get negative 3x minus 5. Those are not the same parentheses. But notice, if we put this and made this a negative 4, okay, then we get positive 3x plus 5. Now my parentheses are the same. The common parentheses is 3x plus 5. The leftovers are x minus 4, and this equals 0. What we've done so far is we put it in standard form, we factored everything. We need to now apply the principle of zero products, okay? I'm going to erase this little portion of board space right here so we can work with this. Going to take this and draw it up here. Sorry to work backwards on you here a little bit, but x minus 4 must equal 0, or 3x plus 5 must equal 0. Of course, here we add 4 and we add 4, and we get these canceling, and we get x equals positive 4. Over here we subtract 5. Okay, let's get rid of that arrow in there. Okay. And these cancel, we get 3x equals negative 5, divide by 3, divide by 3, and x equals negative 5/3. So there are our two answers to this problem, okay? All right, folks, so that takes care of all the numbers through 16. The last problem, okay, from section 5.7, again, just like the homework, they asked you to find the x-intercepts of this problem. Now, we have gone at length to talk about this, but the x-intercepts to a problem, the x-intercepts, you remember, they are the same thing as solutions to the problem. So, you know, you're going to do the exact same thing with this that you just did with these last three problems. You're going to follow all four steps here. First thing you check for is standard form. Yep, all on one side in descending order, set equal to 0. Okay, we got to factor everything, so we check for a common factor, don't have it. Method 3 is the only method that can work here. So 0 is going to equal, well, let's first do this. We got to understand C equals negative 8, B equals positive 2. 4 times 2 makes 8. Negative 4 times 2 makes negative 8. When added together makes negative 2. We need it to be positive 2, so how about 4 and negative 2? That'll make negative 8, but we'll make positive 2. We're going to have a parentheses, and a parentheses is set equal to 0. X and x makes x squared. The positive 4, the negative 2, they drop down. We apply the principle of zero products. X plus 4 must equal 0, or x minus 2 must equal 0. We subtract 4, we subtract 4. We get x equals negative 4. Here we add 2, we add 2. We get x equals 2. Okay? Good. All right, so check it out here. If you say you're done, here's the deal. On the test, because they're asking for x-intercepts, and again, I want you to remember, x-intercepts is where your graph crosses the x-axis. What I'm sharing with you is all solutions to equations are also their x-intercepts in the graphing world. So we're just getting you to understand the concept that solutions and x-intercepts are the same. This sometimes is y. We set y equal to 0. They already did it for you. But here's the deal. An x-intercept is a point on the graph. So it's not just negative 4. It's negative 4 is 0 and 2, 0. Now they're not going to ask you to graph this, but have they asked you 1, 2, 3, 4, 1, 2, 3, 4? You know your x-intercept would be here and here. And we talked about this being, a parabola. Okay, but again, we're not going to have you do that portion of it. I just wanted you to see how it fits in the world you work with. We're going to pause and come back with our last portion of the review. Thanks, Ashley. And everything good on the camera, Ashley?
Yes.
Okay, cool. All right, my fetchers, here's the deal. At this stage of the game, you might consider being done with the review. The first 11 problems on the test, this whole review, you're like, this is so backwards. But part of it is because we're making an emphasis on things that you didn't know, and then going to the stuff that you probably did know last, okay? So here's the deal. First of all, numbers 1 through 11, you got to know how to factor. Now think about this. There are 5 factoring methods. There's 11 problems, so you're going to see these methods, some of them utilized more than once. Really, all of them utilized more than once. I do want you right now, if you're going to practice this with me, get your fetching visual chart out. And if you haven't made it yet, you got to make a factoring visual chart, which means this is one box, and then these 5 methods are the other 5 boxes with their respective steps and an example. I am not, as part of the review, I am not going to write the steps down to each of these methods, okay? That's only going to make me learn it more. You need to write it down. Those steps need to be next to you right now. So get your visual charts out. This needs to be memorized. This needs to be ingrained in you. Yes, you get to use this on this particular exam, but you should know this. So we're going to pause for just a second. Go ahead. Welcome back, fetchers. Okay, so this is going to be a rapid review of our 5 methods of factoring. I really like to keep your lectures to 1 hour because that's what we did on campus. If I review these methods, it's going to put you over an hour. Like I said, if you feel solid in your factoring methods, then you probably don't need this portion of the review. If you need more than this, you're really going to need to reach out to tutoring and have them give you more examples of each method. The first 2 problems on the test, so what I'm trying to emphasize with you is that every single problem that says factor completely, you've got to go through these 5 steps. But the first 2 problems on the test, they actually tell you what method to use. So this is like one on the test here. It says factor out the greatest common factor. Whenever they give you something, they expect a little more from you. This particular problem here, you know, by the way, there's a rubric on this test, which means that every person, the problems get jumbled up. There's over like, I can't even remember, 1,480 or something different versions of the test. So no person can get the same version the way that the problems jumble up. So you're not going to see these exact problems, but you'll see something similar here. So in this problem here, the only method you need to worry about is method 1 because they tell you that. So make sure you read those directions on problems 1 and 2. The rest of the problems will just say factor or factor completely, but this one tells you just use a common factor. The nice thing about that is that you won't need to worry about method 4 because this is a trinomial and A obviously does not equal 1, but you don't have to worry about that in this problem. They're just asking you to pull out a common factor. Do you remember with the common factor, we worry about numbers and letters, okay, which is variables. Okay, so on numbers, we're looking at our times tables, our divisibility tests. What are all these numbers divisible by? If you don't think there's a numerical common factor, you're wrong. Sevens, times table. 7 goes into 21 3 times. 7 times 7 makes 49. And a lot of people forget that 7 times 9 does make 63. Okay? If you see something common in a couple of these, you got to get the calculator out and say, hey, it's 63 divided by 7. Oh yeah, it's 9. So numerically, common factor, okay, we have a 7. And then if you remember letters, it's the lowest degree of the common variable, all right? So we have an x to the 8th, an x to the 6th, and an x. So that x to the 1st is the lowest degree. And then if you remember, we place the common factor under each term in the polynomial. 7x is the common factor. It goes outside the parentheses. The simplified stuff goes down here. 63 divided by 7 is 9. X to the 8th over x is x to the 7th. 49 divided by 7 is 7. X to the 6th over x is x to the 5th. These are the quotient rule, laws of exponents. The same as x to the 8 minus 1, x to the 6 minus 1, if you remember that. These x's cancel. 21 divided by 7 is 3. There's your final answer, okay? All right, now, the second one that we're doing here is your factoring by grouping. So, we've reviewed this. We're now going to review factoring by grouping. Okay, if you remember in factoring by grouping, again, they're telling you to factor by grouping, which means you only have to focus on this method right now, but in any other problem, you would first check for a common factor. Let's go ahead and do that. This is divisible by 2, divisible by 2. That is not. So numerically, it's out. X, 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 no X. Must be common among all terms. So, we do not have a common factor. We're going to redo this problem where we take 2x to the third minus 8x squared, put it in a binomial, always put a plus here, negative 9x, the sign before the term goes with it, plus 36. So right now, you're supposed to have your factoring visual chart next to you with your steps for this grouping method, which would say you take the four terms, you reorganize it into a binomial plus a binomial, always a plus here, a sign before the term goes with it. Then you're going to pull out the common factor from each binomial. That's the next step. These are both divisible by 2, so you have a 2. X to the third x squared, lowest degree of the common variable is x squared, so you're going to put this over 2x squared, put this over 2x squared. Simplify it, 2's cancel, x to the third over x squared makes x. 8 divided by 2 makes negative 4, x squareds cancel. Now we need these two parentheses to be the same. And so if you think about this right now, that's a negative and that's a positive, but that's a positive and that's a negative. So we're going to have to factor out a negative. Okay, the common factor here, both these numbers are divisible by 9. Okay, if you don't see that, okay, remember 3 plus 6 is divisible by 9. Listen, you know that's divisible by 9. Get your calculator out if you don't remember this. 36 divided by 9 is 4. So if you said positive 9, you put this over 9, you put this over 9, and you'll end up with negative x plus 4. These parentheses are not the same. They have to be the same. They're so close. See, and you realize that, oh yeah, if I would have pulled out a negative, this would make this positive, this would make this negative. Because a negative or negative makes these cancel just x, because those are positive. Now, positive and negative make a negative. 36 divided by 9 is 4. The common parentheses is x minus 4. What's left over is 2x squared minus 9. And you're done, okay? This isn't set equal to 0. We're not solving this. Remember, in the beginning of this chapter, or beginning of this test, in the beginning of the chapter, we're just factoring, okay? Okay, we're going to pause for a second. Okay, folks, my purpose in reviewing, factoring methods with you is just to remind you of how the steps work with each method. But again, at this stage of the test, the directives for problems like these two would just say factor completely. So let's do this one on the right first. So the first thing we want to do is check for a common factor, because we have to every problem. We look, there is not one. And then grouping is not an option because there's 3 terms, not 4. And then the 3 terms, it's whether A equals 1 or A doesn't equal 1. A does equal 1, so we're going to say C equals 16 and B equals 10. And we're going to say, yeah, 8 times 2 does make 16, and 8 plus 2 does make 10. Beautiful. This has to be x squared, so x and x. If this was b squared, it'd be b and b. Y squared, y and y. We know all this crap. And then we have plus 8 and plus 2. We're done. This is a wonderful, fast method. We always like this method because we can kick butt and take names. You got a problem like this on the test. I want you to dry your eyes over here and remember this, okay? This one requires you to do a little more thinking. We said this was kind of a nuanced thing. Again, what are we reviewing right now? We're reviewing method 3, but we have to apply this whole thing. But first look for a common factor. R. Do we have an R? No. T. Do we have a T? No. Okay? Numerically, 2 goes into 48. There is no number there. So there is no common factor. Grouping's not an option because there are not 4 terms. And then, our trinomial methods, A equals 1. And so we're going to have C equals negative 48, B equals 2, and 6 times 8 makes 48, right? So if I have 6 times negative 8, that would make negative 2. So that, we got to say basically negative 6 and positive 8. Yeah, that makes negative 48, but when added together it makes 2. So that is going to be our magic pair. But here's the part where you had to think. We have an r squared here, so that's r and r. But we have a t squared here, which means you have to have a t and a t. And now you can drop down the minus 6 and the positive 8. Okay, make sure that you do that properly on the test. Let's pause for a second. Okay, fetchers, our most challenging method of factoring was method 4. Again, you should have your steps of that method next to you right now. So, we look at a problem like this, and the first thing we do is we, again, check for a common factor. This is divisible by 2, also by 7. That is not divisible by 2, nor is it divisible by 7, nor is that. So there is no common fetcher here. X, no X, we're done with that. Factor by grouping, not an option. So we go to the trinomial methods, and A does not equal 1. So we take A times C, which is 14 times negative 3, And 14 times negative 3 makes negative 42. Is that right, Ashley? And b equals 19. Okay? Yeah?
Yeah.
Okay, cool. Just make sure my math's right. So we're going to screw up these students in this cyberspace. Okay? Now, folks, there are some interesting things here about this problem. First of all, if I take this problem and you could, if you know things that when multiplied together make 42, you could jump right into this. But I do want to remind you, again, if you know your times tables, if you know things that multiply together make this, then that's what you do. But if you don't, you take A and C, which is 14 and negative 3, and you get 11. You need your number to be bigger. So on a scale of, if you remember this, 1 all the way to 42. So let me come over here. 1 all the way to 42. Okay? And actually, can we see all this on there? 3 and 14.
Yeah.
Okay? This pair is not working. This number needs to be bigger, so your magic pair lies outside of this. I got to show you guys something fascinating. Check this out, Ashley. It's kind of cool. Okay? So we know that 3 and 14, nothing works in between them, including 3 and 14. And so our magic pair lies outside of this. Well, the only number outside of this left is 2. And then there's going to be a number over here. So we take 42 divided by 2, we get 2 and 21. If we take negative 2 and positive 21, that makes positive 19 when multiplied together makes negative 42. It's just kind of cool, that whole, does it lie in between or outside of thing, okay? So here we go. We now take 14x squared plus 19x minus 3. So the whole thing was finding the magic pair. Then we used the magic pair to break this up into two terms, minus 2x plus 21x. The minus 3 comes down. The 14x squared comes down. And yeah, we take this and we take this and we put a plus in between. Common factor here is 2x. So what we did here is we broke bx up into two terms. We have 4 terms left. We now factor by grouping. We put this over 2x. We put this over 2x. We get 7x minus 1. The common factor here is going to be 7. We put this over 7. I actually screwed this up. Sorry, we put this, it's 3, not 7. My bad. Put this over 3, put this over 3, and we get 7x minus 1. Our common parentheses is 7x minus 1. The leftovers are 2x plus 3, and then we have factored that. This method is challenging. I got to tell you, we don't use really huge numbers. You're not going to see anything monstrous like you did in the homework, like in the thousands and stuff. A lot of times, if you know your times tables, you can figure this stuff out, but this little doesn't lie outside or in between thing can be helpful. Just remember all your steps though, okay? We make sure it's in descending order. We multiply A times C. We find the 2 and factor, make that product of A times C when added together, make B. And then we use the magic pair to break bx up into 2 terms. We'll have 4 terms, so whenever we have 4 terms over there, we factor by grouping, follow those steps, okay? Look at this problem right here. Okay, this is one where if you don't look for a common factor in the beginning, you're going to make yourself pretty freaking miserable, okay? Because, yeah, if you look at this and you go straight to here, because A doesn't equal 1, you multiply 4 times 32, that's a big number. That's 128 that you now have to deal with, okay? And you're going to find things that when multiplied together make 128, when added together make negative 36, and that's not going to be fun for you. That's going to be a ton of work. But if you recognize that this has a common factor, and you're going to get it wrong at the end, okay? After all that work, you're going to get it wrong on the test. Because there is a common factor, and it is 4. And so we put this over 4, we put this over 4, we put this over 4. And I just wanted you to see this because the test does this, okay? Yeah, you're going to see every method. So we just reviewed this method with you. We did a problem over here. We did one earlier in the review today when we were solving quadratic equations in section 5.7 for you. So we've done this 2 times now in this review. But what I want you to see is you have to use this whole process. We look for a common factor. It is 4. We end up with x squared minus 9xy plus 4 times 8 is 32, 8y squared. Okay? So now this 4 comes along for the ride. Don't forget it. Don't leave it out. It's part of the answer. If you don't have that in your answer, you get this problem wrong. C equals 8. b equals -9. Hey folks, -8 and -1 make +8. When added together, make -9. Nice. Parentheses, parentheses. And then remember, x squared is x and x, but don't forget, you got a y squared here. We got a couple of problems on this test where they use this double variable thing where you're going to have to be thinking about that. Now the -8 comes down, and the -1. Do we write -1? No, we just write negative, and you're done, okay? So that's cool. We're going to hit pause real quick. Okay, guys. So the last thing we want to review is special cases. So if we look at this, this was 5-1. Okay, this was 5-1. This was 5-2. This was 5-3. We skipped 5-4. This was 5-5. And then we reviewed them all in section 5.6. Okay, we just reviewed all of them. And special cases was section 5.5. I don't want to lead you down a false path, but on the test, and this has been the case with all of our tests, they follow things on the test chronologically as they are experienced in the textbook. So I got to tell you that you're going to see problems that kind of follow this pattern, but like we showed, you could have a common factor mixed in with some of these. And then, I don't know, they throw one extra in at the end that's just kind of out of sync, okay? But I just want you to see that, these are problems that, I guess what I'm saying is that you're going to see common factor, then you're going to see grouping, then you're going to see the third method, the fourth method, and then this final fifth method, and then they'll throw one in for good measure just to drive you nuts, because that's what we do on tests, right? So we have a binomial here, and we have to ask ourselves, is 25 a perfect square? Yes or no? Yes. Is b squared a perfect square? Yes or no? Yes. Is 9 a perfect square? Yes or no? Yes. Okay? And are they being added? Okay, so if this was 25b squared plus 9, okay, and you're taking the test, the answer would be prime, because it's the addition of these perfect squares, okay? And so remember that, but this is the subtraction, so we're going to take the square root of 25 and get 5, the square root of b squared, which is attached to it up here, so it's attached to it down here. Square root of b squared is b, and then the square root of 9 is your separate term, so that'll be 3. And then Ashley hasn't had the opportunity to sing this like my other children, so we are going to sing this with Ashley, right? We're going to say, put it in a sum, put it in a difference. 1, 2, 3. Put it in a sum, put it in a difference, okay? So we're going to take 5b and put it in a sum, and we're going to take 5b and 3 and put it in a difference. And that's the answer, and we're done. These are super nice, super fast, okay? So why is this trinomial up here? You're like, wait a minute, and we talked about this, okay? So, you have a choice to make here. You can say, all right, I look for a common factor, it's not there, okay, and then grouping, nope, not 4 terms, so you can go straight to method 4, and you can take 36 times -1 and call that negative 36, and know that b equals negative 12. And you could say, yep, let's check this out, and this is actually kind of an interesting problem right here, okay? I want you to really, really, really look at this with me, okay? This problem is a nasty little sucker because I actually was supposed to put +1 there. That would make positive 36, okay? Yes, folks, -6 and -6, when multiplied together, do make positive 36. When added together, make negative 12. And then you could say, hey, 36a squared minus 6a plus 1. How did I come up with that? I took negative 12a, I broke it up into 2 terms based on this. We're going to put a parentheses around these, plus in the middle. Common factor here is 6a. Put that over 6a, put that over 6a. You get 6a minus 1. Okay, and then this looks really close to this, but I got to factor out a -1, and I get 6a. If I put this over -1, this over -1, minus 1. My common parentheses is 6a minus 1. My leftovers are 6a minus 1. And I, in essence, could say that that is 6a minus 1 times 6a minus 1, or what you're going to see on the test is quite possibly this. This would also be the correct answer. Now, one of the things I do want you to recognize with this problem is that, is 36 a perfect square? Okay? And so if you're coming down along the test and you run into stuff that looks like special caseville, okay, you gotta think about, okay, is that a perfect square? Yes. Is that a perfect square? Yes. Is 1 a perfect square? Don't forget 1 is a perfect square. Square root of 1 is 1. Okay? Remember, square root of 36, everybody? 6. Square root of a squared? A. Okay? Square root of 1? 1. Okay? And because that was a minus there, then this would be a minus here, and you would have 6a minus 1 as well. You could have taken that shortcut. Again, we talked about this. That's a tough road to go down, because if that's a plus, then, and that's a plus, then these are both plus. If that's a plus and that's a minus, doesn't work, because we just did that a minute ago. If that's a minus and that's a minus, doesn't work. It's prime, okay? So sticking with this method can help, all right? Folks, we have reviewed everything very, very thoroughly. I got to tell you guys something as we wrap up here. I'm going to stop this video, and I'm going to have one last video I am going to record with you. So actually go ahead and hit stop. Not pause, but stop, and we'll come right back.